Hi everyone, myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering College. Today I am going to discuss about classification of polymers. So in this session I am going to cover the topics: Introduction to polymers, what is polymer, what is monomer, types of polymers, types of polymerization, and differences between addition and condensation polymerization. So introduction to polymer technology. Here polymers form very important components in our daily life. So these will play very important role in our daily life. So the polymers are highly useful in domestic, industrial, and medical fields. So it will useful in domestic, industrial, and medical fields. So we will have applications in domestic, industrial, and medical applications. Here the following reasons for the extensive use of polymers are: most of the polymers are non-toxic and they are safe to use. So they have low densities, means light in weight. So transportation of polymers will be very easy. So they have low densities, means light in lightweight materials. So transportation of polymers is very easy. The polymers possess good mechanical strength, and also they are resistant to corrosion and will not absorb moisture when exposed to the atmosphere. So these are corrosion resistant, and don't they won't absorb moisture when exposed to the atmosphere. Here these can function as good thermal and electrical insulators. So these are corrosion resistance, and this cannot absorb moisture from the atmosphere, and this can function as good thermal and electrical insulators. So these can be molded and fabricated easily. So these can be molded and fabricated easily. So many of the carbohydrates, proteins, enzymes, DNA, RNA are come under natural polymers. So many of carbohydrates, proteins, DNA, RNA, and enzymes which are present in living things. So they are come under polymers, natural polymers. Here, definition of polymer. What is polymer? The polymers, this can be defined as the large molecules formed by the linkage of small molecules. This can be formed by small molecules. Small molecules. This will form polymers. So this is defined as the large molecule formed by the linkage of small molecules called monomers. So these small molecules also called as monomers. Small molecules also called as monomers. So this polymer, it is a macro or large molecule. This is formed by the linkage of monomers or small molecules. So in Greek language, poly means many, mer means units. In Greek language, poly means many, mer means units, means poly units. So a example of polymer is polyethylene. So here this ethylene and number of ethylene molecules linked together, they can undergo polymerization and form polyethylene. So this can be written as CH2 n times. So this is polymer. Means this is a large molecule which is formed by the linkage of small molecules, that is monomer. Here in this ethylene is monomer. Here this is polymer. So this polyethylene is formed by the linkage of small ethylene molecules that are small molecules. So this is called as polymer. So thus the repeated unit of polymer is called as monomer. So what is monomer means? Repeated unit in the polymer is called as monomer. Here if we take one polymer that is polyethylene, here if we take this structure, here we can see CH2. So this is a repeating unit. It is repeated for n times, means this is a monomer. This is ethylene is monomer of polyethylene. So the repeated unit of polymer is called as monomer. The number of repeating units in polymer chain is called degree of polymerization. The number of repeating units in polymer chain is called as degree of polymerization. Here, if we take polyethylene, so here I am writing as 100 or 200. So here the number of repeating units in a polymer chain is called as degree of polymerization. So this example here I am taking ethylene. So 200 repeating units are 200. Here the degree of polymerization of this ethylene is 200. So if another example is, if 100 molecules of ethylene polymerized to give polymer chain, the degree of polymerization is 100. If 100 molecules of ethylene molecules polymerized to give the polymer chain, the degree of polymerization is 100. So here polymer means it is a large molecule. It is formed by the linkage of small molecules. The repeated unit of polymer is called as monomer, and the number of repeating units in a polymer is called as degree of polymerization. Here types of polymers. So types of polymers, here two types of polymers are there. So homopolymer and copolymer. So this polymer made up of only one type of monomer. Homo means same. Homo means same. So this polymer, the polymer made up of only one type of monomer is called as homopolymer. Examples are polyethylene and polyvinyl chloride. Means here, so here monomers here are written as M. So like that, here M is same. M means same. Here we are taking examples of polyethylene, polyvinyl chloride. So we know that polyethylene is structure of polyethylene is, we can denote it as like this. Here repeated unit. So this polymer polyethylene, it is made up of only one type of monomer. So that is ethylene monomer. So whereas polyvinyl chloride, here polyvinyl chloride. So this is made up of polyvinyl chloride monomer. Polyvinyl chloride polymer is made up of only polyvinyl chloride monomer. So these type of polymers are called as homopolymers. Polymers made up of one type of monomer is called as homopolymers. So examples of homopolymers are polyethylene and polyvinyl chloride. Here copolymer. Polymer formed by the reaction between different monomers is called as copolymer. Here homopolymer means only one type of monomer. In case of copolymer, polymer formed by reaction between different monomers. So example is buna S rubber. Here if this is one monomer, this is second. So this is 1 and this is 2. So this is the polymer formed by the reaction between different monomers. Like so example is buna S rubber. So this is one type of monomer, this is another type of monomer. So homopolymer means polymer made up of only one type of monomer, and copolymer means polymer made up of with two different monomers is called as copolymer. So classification of polymers based on the origin. So here natural polymers and synthetic polymers. Here those polymers which occurs in nature, that is plants, animals, and the plants, animals that are called as natural polymers. So the polymers which occur in nature, the polymers which can occur which occur in nature is called as natural polymers. And examples are plants and animals. The plant animals are natural polymers. The polymers which occurs in nature, that is plants and animals, are called as natural polymers. Example, starch, cellulose, proteins, natural rubber. Starch, cellulose, proteins, natural rubber. So RNA, proteins, RNA, DNA, like that. So natural polymers, starch, cellulose, proteins, natural rubber, these are come under natural polymers because these can occur in nature in plants and animals. So what is synthetic polymers? The polymers which are prepared in laboratory are known as synthetic polymers. So synthetic means we have to synthesize the polymers in the laboratory. So these polymers are synthesized, are prepared in the laboratory. So these examples of synthetic polymers are polyvinyl chloride, polyethylene, synthetic rubber, nylon 66. Polyvinyl chloride, polyethylene, synthetic rubber, and nylon 66. So, what is a polymerization? So, it is the fundamental process, the low molecular weight compound converted into high molecular weight compound. That process is called as polymerization. So, in the process, this is a fundamental process. In this process, the low molecular weight means low molecular weight compounds combine together and form high molecular weight compound. High molecular weight compound. That process is called as polymerization. Here, if we take this one unit, that is called as monomer. If we combine two monomers, that is also called as dimer. If we combine three monomers, that is trimer. If we combine four monomers, so that is tetramer. If we combine more than five, so that is called as polymer. That is called as polymer. So this process is called as polymerization. Formation of polymer from the monomers is called as polymerization. Process of forming polymer from the monomers is called as polymerization. Means low molecular weight compounds are converted into high molecular weight compound in the polymerization process. So here types of polymerization. There are three types of polymerizations. So they are addition polymerization, condensation polymerization, and co-polymerization. Addition polymerization, condensation polymerization, and co-polymerization. Here we know that polymerization means process of converting monomer to polymer is called as polymerization. So this is three types: addition polymerization, condensation polymerization, and co-polymerization. So what is addition polymerization? So this is also called as chain polymerization. So this is also called as chain polymerization. So in this addition polymers are formed by adding monomer units without any loss of atoms or groups. Here, monomers are added to each other and we will form addition polymers. So without any loss of atoms or groups. So addition polymerization, in this process, addition polymers, they are formed by the adding monomer units without any loss of atoms or groups. So these polymers formed by the polymerization of monomers containing double or triple bonds. So that is unsaturated compounds. This type of polymers, so formed by the polymerization of monomers containing double or triple bonds. Example, ethylene. So example, ethylene and vinyl chloride. So monomers. So we should have monomers. The monomers should have double or triple bond for the addition polymerization. So in this, the monomers containing double bonds and triple bonds, that is unsaturated monomers, can undergo addition polymerization, then they will give addition polymers. So example, here ethylene, n number of ethylene molecules are taken. So this is also called as ethene or ethene. So this can undergo polymerization and it will form polyethylene. Polyethylene polymer. This is addition polymer. Addition polymer. Here, this is the structure of vinyl chloride, that is CH2 double bond CHCl. So this vinyl chloride undergo polymerization and form polyvinyl chloride. Undergo polymerization and form polyvinyl chloride. So this is addition polymerization or chain polymerization. So what is condensation polymerization? Here polymers are formed from the functional group of monomers with the elimination of byproduct. So these polymers are formed by the functional group of monomers with the elimination of byproduct. So here elimination of byproduct takes place in the condensation polymerization. So and with the formation of new functional group. So this is called as condensation polymerization. So these polymers are called as condensation polymers. Here functional group of monomers. Functional group of monomers converted into new functional groups. Here functional group of monomers, they are converted into new functional group in the condensation polymerization with the elimination of byproduct. Here elimination of byproducts takes place. Elimination of byproducts takes place. So here example, they have taken nylon 6,6 polymer. This can come under condensation polymer. Here the monomer is adipic acid. So that is CH2 4 COOH. So this is combined with hexamethylene diamine. Hexamethylene 6-methylene diamine. Hexamethylene diamine, and it will form condensation polymer. So that is C double bond O. Here C double bond O CH2 taken 4 times. So this is the unit of adipic acid, and this is reacting with hexamethylene diamine, and it is forming CH hexamethylene diamine. So this is nylon 6,6. So this is nylon 6,6 by the elimination of n number of water molecules. Here nylon 6,6, this is formed by the reaction of adipic acid, n number of adipic acid, and n number of hexamethylene diamine. So these will undergo, functional groups can undergo reaction, and this will form C double bond O NH bond and CH2 NH. So this is a nylon 6,6 structure. So in this, functional groups are reacting with each other, and here we will getting new functional groups by the elimination of the byproducts. Here the byproduct is water molecule. So another example is terling. Here ethylene glycol. Here ethylene glycol. So the structure of ethylene glycol is ethylene glycol, 2 OH groups. So this will react with tertalic acid. So benzene. So at para position, 2 carboxylic acids. This is tertalic acid. This is ethylene glycol. These will combine with each other and forms O CH2 O C double bond O So this is the structure of terling. So this is structure of terling. It is condensation polymer. So it is also byproduct here also water. Byproduct in this reaction. This is also here also water is a byproduct. Here terling is formed by the reaction of ethylene glycol and terephthalic acid. So by removing water molecules, we are getting polymer. So here next one is copolymerization. The polymers which are obtained by the polymerization of two or more monomers are called copolymers. So these polymers, these are obtained by polymerization of two or more monomers. So that is called as copolymers. Here two or more monomers. Two or more monomers are combined together and form copolymers. Two or more monomers combine together and form copolymers. So this process is called as copolymerization. Here 1,3-butadiene here 1,3-butadiene, it is reacting with styrene molecule and forming buna S. So here buna S rubber, here buna S polymer, that is come under copolymer. This is come under copolymer. So here butadiene CH2 double bond CH2. So n number of this butadiene reacts with styrene molecules. So here CH double bond CH2. It will form buna S polymers, that is come under copolymer, and this process is called as copolymerization. So the polymers which are obtained by the polymerization of two or more monomers are called as copolymers. So what are the differences between addition and condensation polymerization? Polymers. Here addition or chain polymerization, condensation or step polymerization. So addition polymerization also called as chain polymerization, condensation polymerization also called as step polymerization. Here the monomer must have at least one multiple bond. In addition polymerization, the monomer must have one double bond, at least one multiple bond or one double bond, at least one multiple bond. One multiple bond means double or triple bond. Double or triple bond. Example, ethylene. Here the monomer in condensation polymerization, the monomer must have at least two identical or different functional groups. Here the condensation polymerization, the monomer must have at least two identical or different functional groups. So example, glycol, nylon 6,6. So here we need different functional groups in the condensation polymerization. So in addition, monomer add on to give a polymer and no other byproduct is formed. So in addition polymerization, no byproduct is formed. In case of condensation of polymerization, we can get byproducts such as water and methanol. So in case of addition polymerization, the addition of monomers results in formation of polymer. So here addition of monomers results in formation of polymer. So in the case of condensation polymerization, the condensation reaction between monomers results the formation of polymer. Here the molecular weight of resultant polymers is multiple of monomers molecular weight. So here the molecular weight of additional polymers. So it is a resultant molecular weight of additional polymer. It is a multiple of monomers molecular weight. It is a multiple of monomers molecular weight. Here the molecular weight of resultant polymer is not a multiple of monomer molecular weight, because we are getting byproducts like methanol and water. So here molecular weight of resultant polymer is not multiple of monomers molecular weight. Here Lewis acids or bases are radical initiators or the catalyst. In addition, polymerization. Here Lewis acids, bases, and radical initiators. Lewis acids, bases, and radical initiators are acts as catalyst in the additional polymerization. So, in different molecules are used as catalyst in the process of condensation polymerization. So, depending on the polymer formation, so depending on the polymers, so we have to use different molecules as a catalyst. So, here in case of addition polymerization, we are using Lewis acid, bases, and radical initiator as a catalyst. Here, in case of condensation polymerization, different molecules are used as catalyst in the process of condensation polymerization. Here, common examples of additional polymerization are polyvinyl chloride, polyethylene, and Teflon. Polyvinyl chloride, polyethylene, Teflon, these polymers come under additional polymerization, additional polymers. Here, common examples of condensation polymerization are nylon, bakelite, silicone. Nylon, bakelite, silicone. Here, polyvinyl chloride, polyethylene, Teflon. So, here common examples of condensation polymerization are nylon 66, bakelite, and silicon. So, this is about types and differences between addition and condensation polymers. So, here uh, by by this differences between addition and condensation polymers, here addition polymer or chain polymerization means here the monomer must have at least one multiple bond. So in condensation or step polymerization, the monomer must have at least two identical or different functional groups. Examples of condensation polymerization, here nylon 6 and bakelite. In the case of addition polymerization, polyvinyl chloride and polyethylene. In the case of additional polymerization, no byproducts. In condensation or step polymerization, byproducts are found. Here, the molecular weight of addition polymers, it is a multiple of monomers. Molecular weight, a molecular weight of resultant polymer. In the case of condensation polymerization, it is not a multiple of monomers molecular weight because of byproduct formation such as water and methanol. So this is about differences between addition and conditional polymerization and types of polymerization. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.